In circuit theory, there are two more basic laws. One is called KCL and KVL, named as Kirchhoff current law and Kirchhoff voltage law. Now, the KCL is defined as the algebraic sum of currents entering at a node is taken as 0. So, consider a point where all currents are coming. So logically, if all currents are coming into the conductor, if you summing all those currents, it should not be equal to 0 mathematically. So here algebraic sum means definitely some currents should be leave from that connecting point, and this connecting point is called node or junction. So sum of currents, which currents? Algebraic currents should be equal to 0. So consider this is I1 current, and this is I2 current, and this is I3 current, and this is I4 current. So all current summation I1 plus I2 plus I3 plus I4 should be equal to 0. So mathematically, if you all consider all positive values, so it should not be equal to 0, which means certain currents definitely be negative sign. So which one is taken the negative? Which one has to be taken as negative? So if I consider the incoming current towards the node, incoming current towards the node is taken as positive, definitely current moving away from the node is taken as negative. So in that scenario, my I3 will become negative and my I4 will become negative. Now definitely this summation should be equal to 0. So from this I can write this is as I1 plus I2 is equal to I3 plus I4. So what it means, this is the summation of sum of incoming currents, sorry, equal to sum of outgoing currents. Now this I1 I can write as in terms of charge and time q1 by t, and this is q2 by t is equal to this is q3 by t plus q4 by t. So here the amount of current passing through this current is time at t, means the time scale is same for all the currents. So at this particular instant of time t, how much current is entering at this node and how much current is leaving from this node we are taking. So in all the terms t is constant, t is same, so I can cancel all these. That finally I will get q1 plus q2 is equal to q3 plus q4. So upon observing this equation we can conclude one point, that there is no charge accumulation will happen at any node in the circuit. So the incoming charge is equal to outgoing charge. So how much charge is entering at this node is equal to the same amount of charge is leaving from this node. So this is called law of conservation of charge. Now coming to the KVL, consider a loop having a source V like this. Now my source voltage is given by some voltage Vs, and this is the element R1 and R2. Now, according to the passive sign convention, the current entry portion for the passive elements is taken as positive. So here definitely I will get positive symbol, and here I will get negative symbol. And we know very well source in general it will give the current. So from the source the current leaves from like this. So my current closed loop current will be in this fashion. Now with this polarity of each element and source, the polarity of the source is fixed here, it won't change, but current direction may change. Now there are two ways I can write the KVL equation. Here from the Ohm's law, current I is flowing through this R1 means there is a drop across the R1 taken as V1, and drop across R2 is taken as V2. So according to the KVL, the algebraic sum of voltages in a loop must be 0. So all are added. Again, same mathematical equation should not be equal to 0 for all positive values. So definitely there are certain negative values. Now consider here, to write this equation with a proper sign, one way, if the current is leaving from positive and it is entering at a positive terminal, or simply I can say the current is entering at a positive terminal is taken as a positive, then current entering at negative terminal is a negative voltage. So if you observe, this current I is leaving at positive terminal of the source and entering at negative terminal of the source. So I can write this is as a Vs, and for R1 that is entering at a positive terminal, so I can write as plus V1, and the source the load R2 it is entering at positive terminal, it is at a positive voltage, so now it is 0. So from this I can write Vs is equal to V1 plus V2, and as per definition of potentials we know that this is the work done per unit charge. So I can write Ws by Q, and here this is W1 by Q and this is W2 by Q. Again here Q is same because work done on unit charge. So this thing will be cancelled, and this is the Ws is equal to W1 plus W2, and we know very well the work will be stored in the form of energy. So the total work is equal to the summation of two works. So which means total energy is the summation of individual energy summation. So this is called law of conservation of energy, because here the total energy is converted into two energies. There is no destroying of energy, there is no creation of energy. So my KVL is law of conservation of energy. Here this minus V, yes, in some books, some authors, they will represent that potential drop, and these positive voltages will give written as potential rise. Take some other example. There are two sources like this, and they are connected with a resistor R. Now this is V1 and this is V2. So to write the KVL here, we need to consider some current direction. So that is our wish. We can connect consider this is the current direction like this, or we may consider the current direction like this. So that is your wish. So I'm considering this current direction. So with this current direction, what happened? Here current entry portion for passive element, as current to the passive sign conversion, this is positive, obviously this is negative. And the polarities of the sources are fixed, they won't change. So these are the polarities of the sources. So with this polarity, if you write the KVL equation, then what happened? So positive current is entering at this negative terminal, that is minus V1. Current is entering at positive terminal R, that is VR, and here this is VR. Sorry, this is V2 equal to 0. So my V1 is equal to V2 plus VR. This is the KVL equation.